Hello everyone, and welcome back to another GIS lecture video. And in this lecture video, I want to begin our discussion by talking about the center of spatial data sets. At the center of spatial data sets. And what I want to do before I start talking about specific methods is talk about what it means when I say the center of a spatial data set and why you might be interested in trying to find it. So I've made an example of 6 points. So these are the x coordinates. Actually, let's do it in a different color. Right, so this is the x coordinates, and this is the y coordinates of 6 points. And then I've taken these and I've made a graph of them down here. So this 2, 2 represents this 2, 2 here, and so on. So what do I mean when I say the center of the spatial data set? What I mean is, can we find a point either in the data set or made up of some sort of calculation using the points in the data set that represents what you would call to be the middle of the data set? Okay, that's what I mean when I say the center of a spatial data set, is it's some point that represents the middle of the data set. And hopefully it's not a stretch to imagine why you might want to know where the center of the data set is, right? Some good examples would be if you want to track how data sets change over time, right? Maybe you're dealing with wanting to figure out how crime is migrating across an area. So maybe you have points that represent crime locations in 2010. Maybe you have the same crime, but the locations from 2015 and maybe again in 2020. And you want to see if you can figure out if there's a directional change in how those crimes are moving. Maybe you think that they're migrating to follow population, or maybe you think they're migrating to follow certain demographics, right? You could use the center of the spatial data set as one way to figure out whether or not those data sets are changing in terms of their distribution over time. Right? Another good use of the center of a spatial data set might be you're trying to create a new location for some sort of commercial operation, say maybe a fast food restaurant, or maybe it's a service sector, so maybe it's a hospital, and you're trying to figure out, okay, given all of these other things around here, where might I want to put this where it would have the most impact? So maybe if in the case of a hospital, maybe you're looking at, okay, where do we have the most, where are all the addresses of the locations that these illnesses are coming from? Where can I put a hospital so that it would be have the least distance from from all of these locations to optimize efficiency, right? Or maybe you're a restaurant and you're trying to figure out, okay, where can I put this so that it is the lowest distance from all of the houses in this area, right? So there are a lot of instances where knowing or estimating the center of a set of points is useful. And so one thing I want to point out, the methods that we're talking about deal specifically with the geometry of a point. If we wanted to adapt this to deal with polygons or to deal with lines, what we would then do is we would take the centroid of the polygon or the midpoint of a line. And we're not going to talk about how to do that, but basically you would just convert polygons and lines to points using centroids or midpoints, and then you would apply these methods. So regardless of why we're doing it, now let's talk about how we would do it, right? How do we measure the center of a spatial data set? And there are 3 sort of main ways we can do it. We can do what's called the mean center, which we're going to talk about in this video. We can do what's called the median center, which we'll talk about in the next video. And then finally, we can do what's called the central feature, which we'll talk about in subsequent video. So you might notice by looking at these, we see mean and median, which we've already spent a couple of videos talking about previously in a sort of statistic sense. Now we're going to bring those same concepts over to talk about how we can calculate the center of a spatial data set. So let's go ahead and start our discussion talking about the mean center, right? So we're talking about mean center. And so as the name implies, right, mean or average, right, we're going to be pulling in that same concept that we talked about when we talked about the mean of a data set to figure out the center of a spatial data set. So mean center. So as always, I think it's best to just dive right into the equation and then talk about conceptually what we want to do and then figure out how the pieces of that equation get us to the concept. So to calculate the mean center, we have to do two things. The first thing we have to do is we have to figure out the average, right? Because again, we're dealing with the mean, right? The mean of the x coordinate of our data set, right? Because again, mean center, we're going to find the average coordinate, right? This is the average coordinate, right? And put quite simply, what this is going to be is this is going to be a point that represents the average in the x's and the average in the y's, taken independently of each other. So we're going to find the average in the x's, and just like with our previous example when we talked about mean, right, we're just going to add up all of the x coordinates. So it's going to be that summation of I equals 1 to n of x sub I divided by n, right? Where this summation of I equals 1 to n of x sub I is just going to be adding up all of the x coordinates for all of the points in our data set. And then this n here is going to be the number of points, right? So this is going to be, right, add up all the x coordinates and then this n is going to be the number of points. Right, so this is exactly the same equation as we had for the mean for a normal number line, but now we're just applying it to the x coordinate of our data set. Okay, so let's go ahead and apply that equation here. So sum up the x coordinates. That's going to be 2, 2, 5, 6. Actually, instead of using commas, let's use pluses, right? Because we're adding them together. Plus 7 plus 10 divided by, well, we have 6 points divided by 6. Okay. So if you do the math on that, you end up with a mean x coordinate of 5.33 repeating. Okay. So let's go ahead on our little graph here and find where 5.33 is. So it's going to be slightly past 5, so it's going to be here. So I'm going to make a dotted line here. Right, so we know that the x coordinate of our mean center, so the average coordinate, is going to fall somewhere along this line because this is the x value of our mean center. So the next thing we need to do is we need to figure out the average y coordinate. So that's going to be y bar, right? And so this is going to be the exact same equation as we did for the x, but instead of the x coordinate, we're going to be looking at the y coordinate. So we typically see this denoted as a y, just so we can keep track. Right, and it's going to be the exact same thing. It's going to be the summation from I equals 1 to n of y sub I over n. Right, it's the exact same thing. Right, we're adding up all of, in this case, the y coordinates, and then we're dividing by the number of points. So if we look at our points over here, the top part, right, adding up all of the coordinates is going to be 10 plus 2 plus 4 plus 7 plus 10 plus 3, and then the number of points again is 6. All right, again, same concept, just applied to the y coordinate instead of the x. And if we do the math on that, we actually get a nice even value of 6. Okay. So we know now our average y coordinate is going to be 6. So we go to 6 and we draw a dashed line like that. Right, and then we know that where these two lines cross, right, this is basic coordinate geometry, right? We have a point at the coordinate 5, 333, 6, right? This is going to be our mean center. Right. Okay. So hopefully that made sense. Again, the mean center is just the average coordinate of the x and the average coordinate of the y, and that is our mean center. And this is, again, going to be a good estimate of where the center of the data set is. And visually, you can see that, right? It's sort of an average of the x's, so it's kind of in the middle in the x direction. And then it's the average in the y's, so you can see that it's sort of in the middle of the y's. Put those two together, and you get the point that is the center of the spatial data set using the mean center approach. So hopefully this made sense. I know this hopefully was pretty much a review of the mean again, but hopefully it made sense now that we've applied it in 2 dimensions to get the mean center. And as always, if you have any questions, please reach out. Thank you.